Good evening. We've got some exciting pictures for you now, and the new comer to the sky tonight, Comet Hartley 2. 14 million miles away, and a small comet, but absolutely fascinating. It was photographed a few days ago by a passing NASA spacecraft, and only our fifth comet encounter, and every time it happens, we learn something new about these strange, wraith-like objects. Let me say first a bit about comets. They're not solid, rocky bodies like planets. The only substantial part is the nucleus, usually quite small, only a mile or two across. And that's made up of ices together with rocky fragments. And there may sometimes be a tail or tails. The mass is very low indeed. I've described the comet as being the nearest approach to nothing that can still be anything. Note too, if you see something flashing across the sky, it can't be a comet. A comet is usually millions of miles away and has to be watched very carefully to see any movement at all against the starry background. Hartley is no exception to that. Welcome now to Dr. Chris North. Hello, Chris.
Hi, Patrick.
First, I note you've made a model of Comet Hartley 2.
Yes, we've got a model here that we've made based on the images that had come back from NASA's Epoxy spacecraft that flew within about 450 miles of the comet on the 4th of November.
Why is it green?
Well, comets are often green in the night sky, so we thought it was the most appropriate colour to use. But we can immediately start to see some interesting features about the comet. It's very odd looking. There are very obviously two parts of the comet, two lobes to the comet. This is something that we knew from radar measurements, but now we didn't know its exact shape. We've now proven this.
Does that mean there were two objects that came together, or was it a larger piece of stuff knocked off a still larger body?
Well, we have had asteroids and comets in the past that have looked very irregular in shape. One interesting feature is that the bit in the middle, the bridge, if you like, between the two lobes is very, very smooth, whereas the ends of the lobes are very lumpy and irregular. One possibility is that it was originally two objects, and as the two were orbiting very close together over a long time, millions or billions of years, the very, very weak gravity, which is about 2 million times weaker than the gravity on Earth, has pulled the material off each lobe, the dust essentially on the surface of the material.
Are the two lobes alike?
Well, one's certainly a bit bigger than the other. We don't know yet how alike or unlike they are. In some of the images, one lobe certainly seems to be far more active, but then that's the one in the sunlight, so that's probably why. One feature that has been noticed from ground-based observations is that the variation in how much water ice comes off and how much carbon dioxide ice comes off, and that varies as the comet rotates. Now, it's always been thought that comets should be very uniform, and so it should be the same throughout their rotation, but one possibility is that one lobe has got more carbon dioxide ice in it than water ice, or than the other one certainly.
What is the rotation period?
It rotates about once every 18 hours, but it's almost certainly not just rotating, it's probably tumbling through space as it goes. The other interesting feature that's immediately apparent from the images from Epoxy is the jets. And one of the very interesting features about these images is it's showing there are some jets which appear to be coming from the dark side of the comet, the night side. And we've not seen that before to such a great extent. If you exaggerate the contrast in the image, you can see something like 20 individual sites on the comet that are the source of these jets.
Chris, thank you very much. Well, Comet Hartley 2 is in our sky now, and later we're going to have a look at it. But first, I talked to two of our leading comet experts about where comets come from.
Well, first of all, comets come from two sources. We know there's a cloud of comets surrounding our sun we call the Oort cloud, and that's actually quite a long way away, and this is the source of many of the brighter comets that we see in our skies, comets such as Hale-Bopp. But it was realised in the 1980s that there's a much closer source of comets, such as Comet Hartley 2, which are predominantly in the inner solar system, a very short period of orbits, perhaps 20 years or less. And this is the Kuiper belt out beyond Neptune. Now, the comets, when they're far from the sun, are really small, icy bodies, irregularly shaped, not spherical like the Earth. In fact, if you want a picture of what a comet looks like, you can pick up an aubergine or even an avocado, something like this. We've got an irregularly shaped body, and as it spins, it variously reflects more light and less light towards the sun. And this allows us to measure its rotation period. As it comes in towards the sun's heat will heat the surface, and because it's mostly composed of ice, those ices will escape from the surface. Now, if it's very smooth and equally distributed around the surface, it will be coming from all places on the sunward side. But it could be that some comets have just small areas of exposed ice on the surface, so that as they rotate, you see that icy patch variously illuminated, heated by the sun and eject material, and then go into darkness, and when it's in the night side of the comet it will switch off. And this is another way, by looking at this periodic switching on and off of material escaping from the nucleus, that we can measure its rotation period.
What about comet tails, though?
Well,
what are they made of, and why do they spread out?
The comet tails are how we recognise comets generally, and the tail comes from what happens to the nucleus when it's near the sun of a comet. The nucleus is heated up, the surface ices escape from the surface of the nucleus, and dragging with them the small microscopic dust particles generally that we call comet dust, and that forms first of all the temporary atmosphere, or what we call the cometary coma. Now, the gas and the dust undergoes two different forces. The gas molecules are generally ionised by ultraviolet light and blown back to form what we call the gas tail or the ion tail of a comet. At the same time, the dust particles are being gradually and very gently pushed back by the pressure of nothing else than sunlight itself. Now, to you and me, we don't feel pressure from sunlight when we're out in the garden on a summer's day, obviously.
No,
but for something that's perhaps only 10 times the wavelength of light in size, a thousandth of a millimetre across, it can be pushed back just by reflecting sunlight, and that's then blown back away from the sun to form the dust tail of the comet.
Comets are they have large features that we're used to seeing, a large tail and that, but arguably the most important part of a comet is its nucleus, the central icy core of the comet. Typically they're about a few kilometers in size. They're very dark objects. Now, the reason why we're interested in comets is that they do represent the leftover material from the building of the solar system. They're the only bodies that didn't come together to form the larger planets that we see.
Why are we so interested in Comet Hartley 2?
One of the important things we're going to get from the epoxy flyby of Comet Hartley 2 is it's a relative newcomer to the inner solar system, and so what we're going to get here is possibly a relatively fresh surface compared to some of the other comets we've visited in the past, and so we really don't know what we're going to expect to see when we have the flyby.
The probe, which is going to Hartley 2, had been to a comet before, Comet Tempel 1, and actually knocked a crater in the comet, but the comet was totally unfazed.
Yes, that's right. That was a NASA Deep Impact probe back in 2005. NASA constructed this mission whereby, as it flew by the comet, they would impact the surface. It turns out that the comet actually struck the impactor at about 10 kilometers per second. Since then, the spacecraft, although the spacecraft itself is still called Deep Impact, the mission has been renamed EPOXY because it's a combination of a comet mission plus a mission to observe extrasolar planets, and that's where the name EPOXY comes from.
We have had previous missions to comets, and the first particularly was Comet Halley.
Absolutely right, Patrick. We had a veritable armada of spacecraft going to Halley, and of course that was the first time when we proved that the nuclei of comets actually existed and that they were mostly composed of water ice. The next mission didn't come for over a decade later, and that was the Deep Space One mission to Comet Borrelly. Now, Deep Space One wasn't purely a scientific mission. In fact, it was more of a technology demonstrator mission, but it still gave us our second close-up images of a comet nucleus, and in fact we saw something that was quite different from the nucleus of Comet Halley. The nucleus was smaller. It also had these peculiar smooth areas on its surface, which are still a little bit of a mystery at the moment. And since then, of course, we've had much better images.
Well, after Borrelli, then there was the Stardust mission, which was primarily a mission that was conceived by NASA to visit a comet, fly by the dust tail, and collect some of the samples and bring those back to Earth. It also presented a remarkable opportunity to take images of the nucleus itself. Again, it was completely different from the other objects that we saw. It had very deep craters with flat bottoms to them, just a very, very, very wide-ranging kinds of features on the surface.
The important thing, though, is that when we go to a comet, we know that it's undergone this evolution and this history. And in particular, for Hartley 2, we know that we must be looking at a comet near the end of its life, because when we look at how much material it releases, it can only survive for another 100 orbits before the entire comet's mass has been used up. So whatever happens to Hartley 2 in the future, we are seeing a comet that's pretty close to not being there.
We found out a lot about comets. What do you think is the next step in cometary research?
The Earth's oceans may have been delivered by comets soon after the formation of the Earth's moon. Now, although it's a wonderful theory, we don't have any evidence of that yet, and the evidence will come when we manage to visit one of these comets and measure the ratio of heavy water to normal water. And that's going to happen, hopefully, in 4 years' time, when the European Space Agency's Rosetta mission rendezvous with its target comet and not only goes into orbit about that comet nucleus, but places a lander on the surface, and we're going to learn a whole wealth of information about that nucleus, about the comets in general, and perhaps even about the history of our own planet.
What we all like now is a really spectacular comet, a daylight comet. And I wonder when we're going to get one. We can't tell.
The wonderful thing there is that while the majority of comets these days are discovered by large professional telescopes around the world, searching the skies for objects such as comets and near-Earth asteroids, the majority of bright comets that we see in our sky are still fairly much discovered by amateur astronomers. So it's an open question who's going to discover the next bright comet that we see in our skies.
I wonder when it must be. Well, all we can do is to hope for the best. Stephen, Alan, thank you very much. Now, comets can be exciting, and later on this evening, we're hoping to see Hartley 2. So over now to Pete Lawrence in my garden.
Now, we've got a lovely clear night tonight, but before we actually try and find Comet Hartley 2, we're going to have to wait for the moon to set, because the moon's light makes finding this rather faint comet in the night sky very difficult indeed. Now, we've been following Hartley 2 over the last couple of programmes, and if you've been going out and trying to find it, giving our instructions, and haven't had much success, don't be disheartened. The comet is actually quite tricky to find. Now, its brightness is currently being rated around the naked eye level, and that might fool you into thinking it's going to be quite an easy target. But there is a problem, because the light from Comet Hartley 2 is spread out. And I can illustrate this with a torch and the screen on the telescope front here. Now, with the torch focused, you can see the light quite easily in the centre there. But if I defocus the torch, it spreads its light out over a larger area, and it's much harder to see. Now, there's no extra light coming out from the bulb of the torch. It's exactly the same amount of light, but because the light is spread out over a larger area, its surface brightness is much lower. And that's exactly what's happening with Comet Hartley 2. At the moment, its light is spread out over an area roughly circular in the night sky, and roughly the diameter of 2 full moons across. Now, the first week in November, it's very close to the star Procyon in Canis Minor. And if you're not sure how to locate Procyon, then we need to go back to our old friend Orion the Hunter, which is rising in the hours after midnight. Locate Orion in the east, find his 3 belt stars in the middle of the constellation, and follow them down and to the left until you come to a really bright star, which is Sirius, the brightest star in the entire night sky. If you go up from Sirius, the next bright star you find in a rather barren area of the sky is Procyon. So if you can locate Procyon with a pair of binoculars and then look to the right of it, or to the west of it if you like, That's where you should find this faint fuzzy patch, which is Comet Hartley, at the end of the first week of November. Now you get a better chance perhaps to see it, although it will be slightly fainter, towards the end of the month, because then it passes between two open clusters known as M46 and M47 in the constellation of Puppis. So follow the belt stars of Orion down and to the left again to locate Sirius, and then look to the right of Sirius until you come to the next brightest star along, a bit fainter than Sirius itself. Now if you draw a line from that star back to Sirius and then extend it for 2 times the distance again, that will find those two open clusters for you. They're quite close together and will easily fit in the field of view of a pair of binoculars. Now from about the 26th of November right until the end of the month, the comet will pass between those two open clusters. So that'll give you a great opportunity to locate it. Okay, we're going to try and observe Comet Hartley tonight, but in order to do that, we're going to have to wait for the sky to get as dark as it can possibly get. So we're going to set up our equipment now while we're waiting for the moon to set.
Looks like a Victoria sponge.
Well, I've joined the team in the garden. It's a lovely night, and I ordered it specially, and the comet's high in the sky, so before very long we ought to see it. Meanwhile, welcome Martin Mobley. Nice to see you, Martin. You must have seen some great comets in your time. Which are your favourites?
Well, I think my favourite comet of all, Patrick, was Hyakutake, which I was lucky enough to see from Tenerife. And we had 4 nights under crystal clear skies where there was a comet with a 60-degree tail and a 1.5-degree head just moving across the firmament like nothing I'd ever seen. So I think I'd have to put Hyakutake before Hale-Bopp, which, strangely enough, came the year after. So we had 2 years with 2 great comets. And Hale-Bopp, I think, was the comet that everybody remembers, even members of the general public, because it was visible as a naked eye object for about 4 months or so.
It was more than that. It was the most amazing comet. Halley, of course, was frankly a disappointment.
It was a bit of a damp squib, but of course there have been other comets that maybe haven't been as bright, but have been pretty awesome or pretty mysterious, like, for instance, Comet Holmes a few years ago.
That was a weird thing.
Well, it was magnitude 17 one night, and then it had brightened by 500,000-fold in the space of a day to second magnitude.
Well, I saw it altering the entire look of that part of the sky, and of course it became larger than the sun.
Well, it was quite incredible. Through a telescope it looked halfway between a soap bubble and a goldfish bowl.
It's said that the most loveliest comet of all time was Donati's comet of 1858, and I was talking to Madame Camille Flammarion, and I mentioned this, and she said, oh yes, that was a lovely comet. She'd seen it.
Yes, well, there can't be many people who you can remember who could possibly have seen that comet. That's really going back a long way. But Donati's comet is an interesting one because it was a very rare comet in that it had all 3 characteristics that most comets strive for. It went past the Earth fairly close, went fairly close to the Sun, and it was a large comet, and there are very few comets in history that have had all those characteristics.
Well, the 19th century was good in very bright comets. The 20th century was less good, and I wonder, Martin, when do we get to see the next great comet? Look up there, among all those stars, there must be millions upon millions of comets, and when will we see another really great visitor?
Well,
we can't tell.
No, Patrick, I think that's one of the great things about astronomy. You never know what's happening next.
Well, if one comes, we'll deal with it very well on the sky at night.
Yep.
Martin, thanks very much.
Thank you, Patrick.
Chris, any sign of the comet yet?
I'm just trying to find it in the finder, Patrick, so I can hopefully see it in the main telescope, but it's incredibly diffuse and hard to see against the background stars. So it takes a little while. But Pete, I think you found it in some binoculars and a telescope, haven't you?
I have. I've got it in these binoculars here, and I'm taking some photographs of it over there.
Magnitude 7 or 8?
It's really tricky, Patrick. I wouldn't really like to make an accurate estimate at this time because the sky conditions change the appearance of the comet so much. Some people are reporting it to be about magnitude 5 and visible with a naked eye, but I certainly can't see it with a naked eye, and I'm struggling a bit with binoculars and finder, to be honest. So let's see if I can get it in this one.
I don't think we're far off.
Oh no, you're more or less there actually.
It's a case of persevering and trying to find it in the finder and maybe using averted vision to try and see it.
In this line of a tail.
That's incredibly faint if it's there, Patrick. I can't see it with my eyes, but maybe the camera will pick it up.
Well, it's time to get some thoughts about Hartley 2 from Alan and Stephen.
Hello, Pete.
Hey. Hi.
So what have you got?
Well, my eyes can't cope with the faintness of this comet, so I've been taking photographs of it. So I've got a fairly small telescope here, an 80mm telescope, and I've stuck a DSLR camera on the back of it, and I've been taking sort of 30-second exposures, or this one's a minute exposure.
Okay, that's actually much clearer than you would actually see it by eye, I think.
Absolutely, and there seems to be quite a lot of structure in there actually at the moment, more than I've seen on previous nights when I've been taking photographs.
Yes, you can certainly see some structure there, and that's interesting. Normally we've only seen in some somewhat larger telescopes. So
right, okay.
That's pretty good.
That's quite encouraging then through a small scope. And the colour, I mean, that's quite a sort of greeny-ish colour. What would be causing that?
Well, that's got to be caused by diatomic carbon, C2. Now, it's not coming directly off the nucleus, but there's a parent that we're still not too sure about that comes out and is destroyed by solar ultraviolet radiation. Right. And a product of that reaction is the C2 molecule that you see. And C2 scatters or reflects sunlight right slap bang in the middle of the eye's response when it's dark adapted. So that's why it's looking green.
Well, there are all kinds of things to look out for in the sky in the next few months. And Pete and Paul are over with my 12.5-inch reflector, so let's join them there.
So this is Patrick's wonderful 12.5-inch reflecting telescope.
It is. It's a great one, isn't it? It's especially for lunar and planetary astronomy. Quite apt in a way, because we have some wonderful lunar and planetary events coming up, don't we?
We do, yes.
In particular, on the morning of December the 2nd, if you look out into the east, you'll see a beautiful grouping of the waning crescent moon, Venus and Saturn just above the two of them.
It's gorgeous. When you see that lot together, they just look fantastic. So that'll be in the east in the early morning sky.
That's right, and a nice photo opportunity, I think.
Now, on that night, you'll have the moon very close to another bright planet, the planet Jupiter.
Yes.
But that's not the main event we're looking for. On that night, the Geminid meteor shower reaches its peak.
Wow.
Now, you'll have to wait because the moon will wash out most of the meteors, so you have to wait until the moon is actually set. So that's just after midnight. But that's ideal because the meteor shower actually goes up to its peak in the early hours of the morning.
And Gemini will be quite high in the sky by then as well, won't it?
It will. So if you go out sort of just after midnight, right the way through until dawn, that's when you're likely to see a Geminid meteor. And the rates are pretty high, sort of 100 to 120 metres an hour.
And if you want the moon out of the way, which is obviously what you want, Pete, then what about the winter solstice? Quite special this year because we have total lunar eclipse. I think I'm really looking forward to this, you know, because I think it starts at around about 5:30 in the morning. The moon will be about 23 degrees up. But nothing will really be seen then. It's not until about 6:30 when the Earth's shadow passes over the moon that you'll really start to notice it. And I'm hoping it'll go a lovely sort of dark coppery colour. And
that's right, because sometimes they're quite light, sometimes they're very dark.
They are,
so you think it's going to go dark?
I hope so. They're my favourite ones, the dark coppery ones.
I'll have to take the opposite stance then, and I'll say it'll be light.
And of course, in the event, it'll be cloudy and none of us will see it. But what about January the 4th? We are going to be mightily busy then, aren't we?
That's going to be a manic day astronomically. I mean, it'll start off actually on the night of the 3rd of January, heading into the 4th of January, because then we've got another meteor shower. That's the Quadrantids.
And I always thought this wasn't a very active shower, but that's not true at all, is it?
It can be very active. I mean, you can get rates equivalent to the Geminids up to 100 or 120 meteors an hour. The radiant position, that's the point in the sky where the meteors appear to come from, isn't as well placed as it is with the Geminids. So that actually knocks down the number of meteors you see.
I see.
But the peak occurs in a very, very short time span.
Right.
So if you're up as you're approaching dawn on the 4th of January, that's when you're likely to see the peak of the Quadrantids.
So it's very, very narrow view then to catch this. You have to be quite quick to catch it. And wrap up one, of course, it'll be very cold.
It should be very cold.
But on that morning, of course, we have a partial eclipse of the sun.
Ah, yes.
More than half of it's covered, I think.
It's a fairly big chunk. The sun will be partially eclipsed by the moon as the sun is rising.
So that'd be a wonderful sight. It'd be very strange. I don't think I've ever seen that, actually. And obviously, if you're planning to look, you need to use dark glasses.
Of course, as the sun rises in height above the horizon, so its light gets more intense anyway. So you have to be very careful. But it depends where you are in the country. If you're in the southern part of the country, the sun is rising at about 10 past 8 in the morning.
About 60% of it would be obscured by then.
That's right. But if you're in the north of the country, it's a bit later, so it's about 8:30-ish.
But it's certainly a substantial part of the sun will be quite noticeable, won't it?
It will indeed, yeah. But the eclipse will be over for everybody by about 9:30.
But on the night of January the 4th, we have an interesting thing with Jupiter and Uranus. Jupiter and Uranus have been very close, haven't they, for the past few months?
They've been, actually, Jupiter's been moving backwards and forwards and getting quite close to Uranus.
This gets very close, doesn't it, on the night of the 4th?
It does. Jupiter, which is easy to find, it's that really bright planet you can see towards the southwest as the night's going on. If you look for Jupiter, find it in a pair of binoculars, and then that star you can see just above it on the night of the 4th.
Just to the north of Jupiter.
Just to the north of Jupiter is Uranus. Now, it will be quite close for several days either side of that, but after Jupiter moves away later on in January, that's it until 2024.
So really ought to make the most of it then.
Yeah, definitely.
Well, there's lots to see in the sky. On to our news notes now, and with Chris North. And first of all, we had a flyby of the smallest comet, also of the largest asteroid yet passed, Lutetia.
Yes, this was a flyby of the Rosetta spacecraft past the asteroid Lutetia. As you say, it's the largest asteroid we've flown past to date. It's about 70 miles across, so it's a big beast. And it flew past at a similar distance to the Hartley 2 flyby, about 500 miles away. And it means we get a resolution on this asteroid of about 60 metres, and you can see boulders, large boulders, but boulders. One of the results from the Rosetta flyby is that the asteroid is covered by a 600-metre thick layer of asteroid dust, essentially. Not too dissimilar to moon dust, if you like, but 600 metres thick, so very thick indeed. If you look at some of the craters, they actually look very shallow, almost as they are filled with this dust. You can see the boulders dotted around, and then is that evidence possibly in the centre for a little dust slide down the bottom?
Could well be, I think. Of course, the next asteroid to be studied in detail, not quite yet, is Vesta, number 4. That's quite a different kind of body.
Yes, the Dawn spacecraft is going to go into orbit around Vesta next year. And we've had some new images of it from the Hubble Space Telescope. And it's actually looked at Vesta at several rotation angles, and they've been able to construct a movie of Vesta rotating. So they can try and plan what Dawn will do when it gets there, to get a heads up about what the asteroid looks like, where the interesting features are, and so on.
Well, our last news note tonight is your province. It's way beyond the solar system. The results from the new Herschel telescope.
The image that we've got here is an image that's 4 degrees across, so it's 8 times the size of the full moon. There's about 6,000 galaxies in there, most of them seen as they were billions of years ago. And there were 5 galaxies that, when this image was studied, looked quite peculiar. They were very red and very bright. Now, this is a far infrared image, so it's looking at dust and gas in these galaxies. And these galaxies that were particularly bright were possibly thought to be gravitational lenses, so they studied them in more detail, and they found they in fact were. So what's happening is that when you look in optical light with something like the Keck telescope, you see a foreground galaxy. And the mass of that galaxy is actually bending the light from a much, much more distant galaxy behind. And that distant galaxy is what Herschel's seeing. Now, what this allows us to do is study these very distant galaxies, seen as they were 11 billion years ago, so when the universe was at a third of its current age. You can't see them in optical light because they're so shrouded in dust and essentially invisible to optical telescopes. But in far infrared light, we can study them in much more detail and get a better picture of how galaxies, relatively normal galaxies, were evolving in the very early universe.
Chris, thank you very much. Please don't forget to send in your questions for our 700th Sky at Night programme, and send them into bbc.co.uk/Sky at Night. And when we come back next month, I'll be talking about the Great Bear in the Sky. So until then, good night.